Good morning, one and all. My name is Arjun Joshi. Uh, this is nothing but our simulation and op-amp circuits laboratory for our fourth semester electrical and electronics engineering students. Okay, it is a VTU syllabus. Okay, we already seen many examples or experiments in our last videos. You can refer that experiments around 7 experiments are done, both design part, theoretical part, and in multisim platform also. Okay. In this session, let's we start our experiment number 8 as per our series. It is a 8th experiment. Oh, okay. After completion of precision rectifier, uh, let's move on to the experiment 8. That is nothing but design and analysis of op-amp based design and analysis of op-amp based. Here we need to discuss around 4 experiments like adder, that is nothing but a summing amplifier, and second one subtractor, and then integrator, and then differentiator. We need to understand, or we need to discuss, or we need to simulate 4 experiments in the experiment number 8. Okay, adder, subtractor, integrator, and then differentiator. We know aim, operators required, and then theoretical concepts. Okay, design, everything is same. Okay, now let's we understand about the theoretical part of summing amplifier or summing amplifier or uh, adder. Okay, adder. Okay, this is a circuit diagram of inverting configuration summing amplifier. Okay, you can take non-inverting also. Here I'm going to consider the inverting configuration of summing amplifier. Here everything is remaining same like our inverting amplifier, but here I'm going to give number of inputs, three number of inputs or three voltages VA, VB, VC through the resistors to the inverting terminal, and then feedback resistance, and then offset minimum resistance ROM. We can neglect this one, or we can consider. Okay, and then RL. We can neglect RL and ROM also. Okay, I think all of you understand the circuit diagram. Summing amplifier, we need to amplify it. We need to add all the three voltages like VA, VB, VC. VA, VB, VC will going to be had. Okay, V naught is equal to VA, VB, VC. But here we need to consider amplification also. That is nothing but gain minus RF divided by R. How this equation will going to come? This equation like V naught is equal to minus RF divided by RA, VA plus RF divided by RB, VB plus RF divided by RC, VC. How this equation will going to come? Let's we understand now. We need to apply KCL at node V2. Okay, we know the virtual ground concept. Virtual ground concept is nothing but here I'm going to consider this VI to the ground, so that is nothing but VI is equal to 0. Here IB1, that is what is the current flow here, that is also 0. That means V2 is also equal to 0. V1 equal to V2 equal to 0 according to the virtual ground concept. We know the virtual ground concept, that is nothing but V1 equal to V2 equal to 0. Okay, in future let's discuss that one. Here we need to consider apply KCL at node V2. For this node V2, we need to consider our point down first one. First we need to point out V1, V2, V0. Okay, for point V2 we need to apply, for node V2 we need to apply KCL. What is the KCL? The statement of KCL, incoming current is equal to outgoing current. But what are the incoming currents here? IA, IB, IC, and then outgoing currents are IF, IB, 0. Okay, I'm going to write down the equation IA plus IB plus IC equal to IF plus IB2. IB2 here also 0, so I'm going to consider directly 0. Okay, what is the current remaining? What are the equation remaining here? IA plus IB plus IC equal to IF. Okay, for the IA, we need to consider the Ohm's law. Okay, here, what is the difference? Ohm's law. Okay, we need to consider Ohm's law is equal to V by R. Okay, for IA, what is the voltage here? VA minus VE, the difference voltage VA minus V2 equal to VA minus V2 divided by RA. Okay, V by R formula, and then VB minus V2 divided by RB plus VC minus V2 divided by RC equal to, what is the IF here? We need to consider V2 minus V0 divided by RF. Okay, what is the V0? V2 according to virtual ground concept, V2 equal to 0. We need to substitute here 0, 0, 0, 0. What is the equation come now? VA by RA plus VB by RB plus VC by RC divided by equal to minus V0 RF. Okay, this equation will come here, minus will come. Okay, why? Because here V2 will going to be 0. So that's why minus V0 RF. Okay, I'm going to take this RF to the RHS to LHS. Now the equation will become V0 equal to minus RF VA by RA plus RF VB by RB plus RF VC divided by RC. Okay, V0 equal to this equation, the final equation according to the circuit diagram. You are going to take consider this equation directly. Here, with the help of this equation, we can find out the real-time equation for summing, scaling, averaging. How we need to find out? We know the basic equation now. Okay, consider this equation. If summing amplifier, I'm going to consider summing amplifier. If RA, RB, RC equal to R means RA 1K, RB 1K, RC 1K means the overall all the resistance value same. Then we need to consider it is called summing amplifier. I'm going to consider V0 equal to minus RF because here RA, RB, RC values are same. So that's why I'm going to consider all the values are equal. So minus RF divided by R, VA plus VB plus VC. Okay. Now, if the gain of the circuit is 1, what do you mean by 1? RF by R, 1. The final equation is minus VA plus VB plus VC. Now let's understand scaling. Scaling is nothing but when RA not equal to RB not equal to RC. Different values of RA, RB. If in the question they give, if they give RA not equal to RB means different values, RA 3K, RB 1K, RC 2K. In that time, the scaling amplification will going to be done. Okay, V not equal to minus RF divided by VA RB plus VB RB plus VC RB. Okay, we need to solve one and other example for that concept. Averaging amplifier is nothing but very simple. V naught equal to minus VA plus VB plus averaging plus VC divided by 3. Okay. You can consider the output voltage is equal to average of all the input voltages RA, RB, RC equal to R. We know the RF divided by R equal to 1 by N. We need to consider this RF divided by R. This equation RF divided by R equal to 1 by N. 1 by N is nothing but number of inputs. In number of inputs. Number of inputs, how much here? 3 inputs. VA, VB, V3. 3 inputs. Average madre, we are going to get the V0 value. So this is how we need to find out the equations for summing amplifier, scaling amplifier, averaging amplifier. Here you need not to think more. You can directly take the equation of V0 equal to this equation and then find out the concentrate on summing amplifier. Okay. Okay. Take down this example. In the above circuit diagram, VA equal to 1, VB equal to 2 volts, VC equal to 3 volts, RA equal to RB equal to, so all the 3 resistors values are same. So we need to consider this equation. Okay. Now RF equal to 1, ROM is equal to 270. You can neglect this ROM and then supply voltage 15 volts and then determine output voltage. You need to consider this equation, summing amplifier equation. V naught equal to minus RF divided by R, VA plus VB plus VC. What is the RF value here? 1 kilo ohm. 1 kilo ohm divided by, you need to consider this minus also, and then R value is nothing but same, RA, RB, RC equal to R value. R, the equation 3 kilo ohm, 3 kilo ohm. What is the input voltages? 1 plus 2 plus 3. Okay, you can solve with the help of calculator. You will going to get minus 2 volts. Okay, the value is equal to the average of all 3 inputs with negative sign. Why in the negative sign? Because we are going to connect the supply all the 3 inputs to the inverting terminal. So that's why we are going to get the output in minus. Okay, minus sign, with the minus sign. Okay, I'm going to consider another example, very simple. Here the problem is a little bit tricky because in the previous problem, all the resistance values are same, but here all the resistance values are different. We need to consider the not summing amplifier, scaling amplifier. Determine the output of summing amplifier or scaling amplifier with the given DC input, means all the resistors are different. So we need to consider different formula. What is that formula? You can apply the KCL and got the voltage, Ohm's law. We need to apply Ohm's law, and then finally I'm going to get this equation. Which equation we need to consider? This equation. V naught equal to minus RF. This equation. Okay. You need to consider this equation. Here I'm going to consider. Uh, I'm going to consider different resistor value, means V by R. V is nothing but 10. Here we need to consider RF is nothing but 10. RF divided by R. R is nothing but here RA 4K 4K. VA is nothing but 1 volt plus 10 kilo ohm RF into minus 2 divided by 2K plus 10K divided by 1K into 0.5. This volt. Okay, you need to solve this one. You will going to get 2.5. Okay, this is how I'm going to solve the equation. Okay, with the help of different formulas. Okay, you can concentrate on this, only this problem also. Only this problem also. It's very simple. And then, okay. Okay, let's we understand the same problem in the multisim. I'm going to consider the second example first. The input V1 is 1, V2 is minus 2, and then V3 is 0.5 according to this problem. According to this problem, 1 minus 2, 0.5, 4K, 2K, 1K. 4K, 2K, 1K, and then feedback resistance 10 kilo ohm. I'm going to connect to the input to the inverting terminal. Here DC power plus we need to connect, and then minus we need to ground. Okay, and then in non-inverting terminal I'm going to connect to the ground, and then output I'm going to connect to the multimeter. You can use multimeter, or we can use oscilloscope also. Okay, I'm going to run the program or simulation example. Now click on the multimeter. I'm going to get the perfect answer, that is nothing but 2.5. Okay, 2.5. According to the problem, what is the output voltage? According to the calculation, output voltage equal to 2.5. Okay, 2.5. Okay, 2.5. Yes. Now I'm going to consider the this example. VA equal to 1, VB equal to 2, V3 equal to, VC equal to 3. I'm going to change the value. VA equal to 1 volts only. VB equal to, what is the value? 2, 3. 2, not minus 2, 2, 3. Okay. And then what is the resistance value? All are the same value, 3K. 3, 3, 3. What is the feedback resistance value? Feedback resistance value is nothing but 1K. 1K. 1 kilo ohm. Okay. Yes. I'm going to run. We need to get minus 2. According to the calculation, we need to get minus 2. Minus 2. Okay, approximately it is equal to minus 2. It will shows minus 1.9. Okay, it's okay. Okay, we need to write down here serial number 1, VA equal to 1 volts, VB equal to 2 volts, VC equal to 3 volts. Average is not theoretically minus 2, but practically it is a minus 1.9. Okay, then I'm going to show you how to see in the oscilloscope. Okay, here it shows DC. So that's why it shows single line. Okay. Approximately it covers 1 box, 2 box, or 2.2. That is nothing but Uh, it should give 1.2 approximately, exactly 2, but it shows one box 1.2, 1.4. It shows 2.6. So according to the calculation, it should show 2 volts. Compared to oscilloscope, the multimeter will going to give appropriate reading. So you can consider the multimeter reading only. Okay. Thank you. Thank you so much. It is a summing amplifier. In future videos, let's understand the subtractor. Okay. Subtractor amplifier. Okay. Uh, Another one thing is here we not only get the addition value or adder additional value, but it will also amplify the output with the help of this feedback resistance or with the help of gain. Okay, so that's why it shows here minus RF by R in the second problem also, RF by RA. Okay, here in the second problem we have different RA, RB, RC. So that's why I'm going to consider here everywhere. In the previous problem, we are going to consider only R because all the values are same here, 3 kilo. Okay, I hope all of you got it. Thank you so much. Let's be meeting the future videos. Thank you so much.